Action.
In this video, we're going to talk about how filtrate processing is different in a situation where a person is not in water balance. So let's just remind ourselves that when a person is in water balance, that means the amount of water coming into their body is roughly equivalent to the amount of water leaving their body. So their kidneys don't need to do anything special as far as trying to retain water or prevent the loss of excess water, because there's plenty around so they can afford to get rid of excess water. There actually is excess water in the system, okay? And in those situations, the filtrate processing is really going to be exclusively in the proximal convoluted tubule, descending limb of the nephron loop, and ascending limb of the nephron loop. Okay? So if we now are in a situation where the person is in what's called negative water balance, now we have to do something different, because in negative water balance, there's less water coming in than going out. So the body has to switch from time of plentiful water to water conservation mechanisms. And one of the major shifts that will happen is that the change in the tonicity of the blood, combined with the effect of the loss of volume on blood pressure, will initiate the RAA mechanism, or renin, angiotensin, aldosterone mechanism. Now, I'll talk about the mechanism and how it specifically unfolds in another video, but we're just going to look specifically in this video at how the filtrate processing changes and which parts of the renal tubule are affected. Okay, so the end result, as far as the kidney is concerned, for the renin, angiotensin, aldosterone mechanism, is that two hormones are produced and released that will change the behavior of these sections of the renal tubule that we didn't use when we were in water balance. One of those hormones is aldosterone. Aldosterone is a steroid hormone that is released by the adrenal cortex, and when aldosterone is present, it will initiate reabsorption of sodium ion, and it affects both the DCT and the collecting duct. Okay, so in a situation where aldosterone levels become elevated for the purposes of water conservation, we're going to see that sodium ion reabsorption will be enhanced. Okay, now ADH is another hormone that is released, and this will be released from the posterior pituitary, and ADH stands for anti-diuretic hormone. Okay, so if you think of what a diuretic does, which is essentially it causes you to increase urinary output, something that's anti-diuretic is going to have the opposite effect. It's going to decrease urinary output. Okay, so ADH is going to affect reabsorption of water in the collecting duct. Okay, so we'll see that in addition to sodium ion reabsorption increasing, we're also going to have increased reabsorption of water, specifically in the collecting duct. Okay, now without these steps, we would have produced dilute urine. Okay, so if our processing ended here, we would have reabsorbed 90+ percent of the material that we originally filtered, and only 10% of that would be leaving the body, or less would be leaving the body in dilute urine. Okay, if we switch to conservation mode, we're going to reabsorb the vast majority of that material that would have been in that dilute urine. So instead of producing a large volume of dilute urine, we'll now be producing a small volume of concentrated urine. Okay, now this is, it's important to note that this is just a conservation method. This is trying to kind of keep as much water in the body in a situation where our receptors are telling us that water levels are too low. It cannot create new water. So the fix for this really is that increased water intake must be accomplished. This is really just a stopgap measure to get us through that time when we might not be bringing in enough water so that we can get to a place where our water intake can go back to normal or increase. Okay, and that sums up this section.